Welcome to LearnFast tutorial. If this is your first time of seeing my video, consider subscribing. Follow my page. Please like and share this video to your friends. Let's talk about the chain rule method of differentiation. Now, it is important to know that the only time we have to apply the chain rule method of differentiation is when we have a complex function. In other words, when we have a function inside of another function. Let's take from our formula, we have that y is equal to f of u, where u is equal to g of x. So we know that u is a function, and u is equal to g of x. And then u is inside of another function, which is y. So this is a perfect case or perfect scenario where we can actually apply the chain rule method. And the way we go about this chain rule method is basically differentiating the outer function, keeping the inside function the same, and multiply by the derivative of the inner function. In a short while, we are going to see how we can actually use the chain rule method to obtain the derivative of this function we have in our list. So from our basic knowledge of differentiation, we are going to differentiate the outer function. And we're going to move this power of 4 up front and take away 1 from this power. And then leaving everything we have inside of the function the same, and then multiply by the derivative of the inside function. So dy dx will be equal to, and we're going to move 4 up front and take away 1 from 4, we'll have 3 remaining. And then we're going to repeat everything we have inside of this function, which is 3x plus 1, right? From the first step. So then the second step, we're going to multiply by the derivative of the inside function. And if we differentiate 3x, we have 3. And then 1 is a constant, so the derivative of 1 is 0, so we don't need that. Then if we tidy up, we have 12 3x plus 1, all raised to the power of 3. So this is basically the derivative of this particular function. And then from our second problem in our list, we want to get the derivative of this particular function. And then in the same vein, we are going to move 7 up front, right? So we have that 7. Then repeat everything we have inside of this function. We have that 7 will be equal to x squared minus 2x minus 3. Then take away 1 from 7, so we have 6. Then we're going to multiply everything we have here. We're going to multiply by the derivative of the inside function from our formula that we have. So if we differentiate x squared, we have 2x. And then if we differentiate negative 2x, we have negative 2. Then this is a constant. If we differentiate it, is basically 0, so we don't need that. So this is basically the derivative of this particular function. You don't have to begin to expand this. And then if we from our third problem, from the problem we have, which is the next problem, we are going to see how we can actually get the derivative of this trig function right here. We know that the y dx. Now we have a bigger function, which is sine. This is actually a trig function. Then we're going to differentiate this sine. In this case, there is no power, right? We're going to differentiate sine. Then leaving everything we have inside of this bracket, which is this function, inside of a bigger function, which is this trig function, right? This sine function actually. And then we're going to differentiate this sine. Then leaving everything constant, then multiply by the derivative of the inner function. And we know that the derivative of sine is cos actually. So we'll have cos, repeating everything we have inside of the bracket, we'll have cos x squared minus 3x. Then multiply by the derivative of x squared minus 3x. So that will give us 2x minus 3. You see, so this is actually the derivative of this function. At first, you differentiate the outer function, right? You differentiate the outer function, which is sine. And if you differentiate sine, take for instance sine x, you obtain cos x. So we differentiated this sine, that's what gave us this cos we have here. Then leaving the inside function the same, right? and then multiply by the derivative of the inside function. Cool. And then for the final question or the final problem we have in our list, we are going to apply the same knowledge to obtain the derivative or the derivative of this particular function. Now, in this case, we have everything raised to the power of 2, right? Good. So we are going to move these 2 up front. Repeat everything we have inside of the bracket. We have cos 2x. Then we take away 1 from 2. So basically, there is a 1 here. It's invisible. It does not matter. And then we are going to differentiate the inside function. If we differentiate 1, is basically 0. So we don't need that. And then we are going to differentiate cos 2x. We know that this is not cos x. Like we say, differentiating cos x is negative sine x. But then this is cos 2x. So we have a function 2x inside of this full function cos 2x. So we are going to differentiate the cos first. This 2x was kept constant when we differentiated cos x, right? And so we have negative sine x. Then we now also differentiated the inside function, which is 2x, and that's what gave us this 2 we have right here. So we can actually tidy up this. Since everything is multiplying, we can actually tidy up this to be 4 into 1 plus cos 2x into negative sine 2x, which is the correct derivative to this particular function. So it's quite easy to understand. What you just need to identify is to know the outer function. In this case, where we have your sine, we know that sine is the outer function. So you get the derivative of this sine, or as the case may be, whatever question you have, you get the derivative, keeping the inside function the same, and then multiply by the derivative of the inside function. So that is that for this class. Hope you did enjoy the video. Please make sure you share this video to your friends, like this video, drop your comments, subscribe to my channel. Hope to see you on my next class. Bye for now.